Vietnam, the ever-increasing demand for air travel has led to our cooperation in the building of a new terminal at Noi Bai Airport. In the construction field, Japanese-style safety and quality control have been taught to a total of 74,134 local construction workers. As a result, work has been completed ahead of schedule and with 0 fatalities. There has also been a transfer of technologies featuring Japanese-style expertise in areas ranging from aircraft fuel supply and hand luggage control through to commercial facility development. This has led to Noi Bai being selected in 2016 as the world's most improved airport. Airport development. Japan's construction and operation of its airports has been highly evaluated globally. 3 of the 2016 World's 10 Best Airports were in Japan. They have also made great achievements in expanding income from sources other than the aviation sector, such as through development of commercial facilities within airports. Using these strengths, Japan offers complete solutions for airport development all around the world. In construction for Terminal 2 of the Noi Bai International Airport in Vietnam, there has been a transfer of Japanese-style expertise, covering everything from civil engineering works through to refueling, baggage management, and commercial facility development. This has led to Noi Bai being selected in 2016 as the world's most improved airport. In the Philippines, the Eco Airport concept was adopted in the construction of the new international airport at Bohol, using Japanese technology to conserve the local environment, such as the coral reefs. Solar power and an emissions processing system for construction were introduced, and airport development was carried out with consideration for the environment. In Mongolia, comprehensive development of the new international airport at Ulaanbaatar is being carried out in the short time frame of 28 months to respond to local climate conditions where it is difficult to perform outdoor construction during the winter. Wide-ranging technical support for the local staff, covering everything from airport management to organization building and fee planning, is also being carried out during the period after opening the airport, including technological training in snow removal and machinery management at airports in Japan. Japan will provide integrated support for both equipment and experience in airport development around the world. The Philippines sits right on the Circum-Pacific Belt. We are implementing a widespread disaster prevention system that gathers data to reduce damages from earthquakes and subsequent tsunamis. Throughout the Philippines, strong motion seismographs, and tide gauges now collect real-time data through a system that utilizes satellite transmissions. We are also working to build a framework for rapid information distribution in times of disaster. Area development. For area development, it is important to strive on the basis of a long-term perspective, such as development of master plans and roadmaps. Japan is contributing to area development around the world by making use of our experience in urban reconstruction in the 60 years since the end of World War II. In Thilawa, Myanmar, area development of the Special Economic Zone has been carried out through joint efforts of Japanese public and private sector. Japan offered comprehensive support in cooperation with Myanmar, covering the development of a master plan, support for design of a legislative system, investment in a special purpose company for development, peripheral infrastructure development by ODA, construction of an industrial zone, and attraction of factories. After the start of operations of the SEZ, 79 companies joined in from 17 countries and regions, including Japan, Myanmar, and the US. In the future, 50,000 to 60,000 new local employees will be created and will contribute to the development of the Myanmar economy. In Andhra Pradesh, located in southeast India, the state government of Andhra Pradesh has actively engaged in a new state capital in Amaravati. The Japanese government and private companies have, through talks with Andhra Pradesh, proposed advanced urban development plans which take advantage of Japan's cutting-edge technology and know-how. Japan has cooperated with the state capital development. Bridge construction. Japan's bridges have a proven track record of construction, supported by the highest level of technology in the world. In Vietnam, Japan's unique steel pipe sheet pile well foundation construction method for soft ground was adopted in construction of the Nhat Tan Bridge. This construction method was praised for its effectiveness and has been recognized as a standard in Vietnam. In Cambodia, in order to eliminate bottlenecks on international roads there, construction of the Tsubasa Bridge was carried out with Japanese grant assistance. On average, 1,000 locals were employed every day. Japan's construction technology was transferred to many young local engineers. Japan's demonstration of high quality is not limited to new bridges. The Matadi Bridge in the Democratic Republic of the Congo, which was constructed in 1983, continues to be maintained by the local transit authority based on advice from Japan. We have continued to help maintain its quality for over 30 years following the bridge's completion. The anti-corrosion cable system that was introduced for the Akashi Kaikyo Bridge prevents the development of corrosion by establishing a dehumidification system for the existing suspension bridge cables. This technology has been adopted in the second Bosphorus Bridge in Istanbul, Turkey, where it has contributed to reduction of maintenance cost. Japan will contribute to global transportation infrastructure maintenance by means of its great expertise in bridge development. We are introducing ultra-supercritical thermal power to Taiwan. Our USC plants have set the world's highest standard for efficiency. This technology adds efficiency to coal, thanks to cost-effective operations, solving the long-debated burdens on the environment from coal-fired plants. By customizing our USC plants to work with various types of coal, we've minimized the wear on the facilities, and it's possible to maintain heat efficiency over many years. With long-term maintenance of a high level of performance, Japanese infrastructure contributes to life cycle economic efficiency. Use of purified ocean water has been advancing in Saudi Arabia since the 1970s. Japan quickly stepped in to help by providing unique permeable membrane technology. The qualities of ocean water resources differ considerably from region to region. In Saudi Arabia, the properties of ocean water particular to the Middle East had caused problems, including membrane deterioration. But we managed to maintain a high level of performance by sending researchers to Saudi Arabia and improving the materials and maintenance methods. Desalination. Desalination guarantees industrial and drinking water in countries poor in water resources. In recent years, the reverse osmosis method for desalination, where purified water is obtained by applying pressure to salt water and passing it through a special osmosis membrane, has begun to be used more widely. The reverse osmosis method is significantly more energy efficient, and it makes it possible to keep down the cost of desalination, together with an exceptionally low amount of CO2 emissions. Japan quickly took on technological development in this field and now leads the world. Japan actually has 70% of the global share of reverse osmosis membrane production. The performance of the reverse osmosis method is significantly affected by the composition of the salt water. The materials and the maintenance methods of the membranes should be modified depending on the composition. For instance, the plant in Saudi Arabia ran into trouble when the performance of the membranes decreased after 2 years of operation. Japan organized an emergency response team and dispatched experts to the plant sites. The cause was determined to be the heavy metals found in the Red Sea, and performance was improved. Because of Japan's high-level capabilities in research and development, we are able to provide reliable desalination plants in response to the regional conditions of saltwater. Andhra Pradesh, located in southeastern India, is building a new state capital for 2024 and beyond. We will provide long-term cooperation with this plan as part of our All Japan system, bringing together government and the private sector. This takes in everything from grand design and infrastructure maintenance through to building public facilities and inviting industries. Our experience with rapid infrastructure development gives this new region support in developing and implementing at such a large scale. In the Republic of Botswana, we are supplying broadcasting equipment as well as technology to support production of programs for high-definition TV broadcasting. After setting up a company that specializes in data broadcasting, we are now educating and promoting personnel. We have also launched a cooperative R&D project to introduce and improve education, medical care, disaster prevention, and electronic government using digital broadcasting. We are working to use digital broadcasting in new ways and create local industry. Integrated cultivation of industry with Japan stimulates spontaneous growth all over the world. Geothermal power generation. Geothermal power. It creates energy from natural heat sources existing underneath the ground. Because geothermal power needs no fuel for electricity generation, operational costs are low and the environmental impact is exceptionally small. Furthermore, energy output from geothermal power is stable compared to other sources of natural energy and can therefore serve as a baseload power source. However, the development stage is usually faced with issues such as the inherent risk in finding underground resources and the necessity for large capital investments. Japan has experience in providing development schemes which combine preliminary surveys to minimize development risk and financial support through relevant feasibility evaluations. Japan possesses the highest level of geothermal turbine technology in the world. Japan provides reliable geothermal turbines which are resilient to deterioration caused by sulfides contained in the underground resources. And Japanese share of geothermal power in the world reaches at 70%. Japan is also actively working with technological transfers to other countries. For example, we have dispatched Japanese experts to local sites in Kenya. They carried out technological guidance in test drilling and ground surface surveying. In addition, Japan receives trainees from other countries at Japanese corporations and universities. Japan's support for the human resources development contributes to the realization of sustainable geothermal development. GTCC Power Plant. Gas turbine combined cycle (GTCC) power generation has high efficiency and low environmental impact, such as CO2 emissions, when compared to other fuels. It also stands out for the ease with which one can change output in response to energy demands. GTCC achieves a high level of efficiency by turning a steam turbine by recovering exhaust heat from the energy production of gas turbines. Japan possesses the world's most efficient gas turbine technology, and with GTCC, we have realized the highest level of thermal efficiency in the world at 62%. We also promote more efficient GTCC technological development. Japan possesses comprehensive GTCC technology and can provide plants which meet a diverse array of needs. Japan is committed to long-term operation and maintenance. We are actively pushing for the localization of operational and maintenance management technology in many countries. We have also signed long-term service agreements in many countries and carried out gas turbine maintenance and management, the provisioning of replacement parts, and remote monitoring, continuing our support for stable GTCC operations. High-speed rail. Japan began service on the world's first high-speed rail, the Shinkansen, in 1964. Now, more than 50 years later, the Shinkansen has carried over 10 billion passengers in total with no loss of life. The average delay is under half a minute. The overwhelming quality of Japanese high-speed rail is spreading throughout the world. A high-speed rail was opened in 2007 in Taiwan. As a result of human resource training and transfers of Japanese-style safety management technology, the train has realized a high level of service stability with a suspension rate of 0.42% and an average delay of 15 seconds. Even during the magnitude 6.4 earthquake in 2010, no passengers were killed or injured. In Britain's plan for intercity high-speed rail, Japan is not only supplying the train cars, but has also concluded a long-term service agreement for 27.5 years. Japan will provide medium and long-term support for accurate and safe service, such as introducing the latest remote maintenance systems. Japan is also cooperating with countries such as the US, India, and Thailand in high-speed rail ventures. Saving energy by reducing the weight of cars and adopting regenerative brakes. Smaller tunnel construction thanks to airtight train cars. Noise control engineering, which fulfills the strictest environmental standards in the world. The comprehensive quality of Japan's high-speed rail development brings with it a significant return on investment over the entire life cycle. ICT solutions. Japan possesses one of the highest levels of information and communications technology, ICT, in the world, as well as a proven track record in this field. For instance, we have contributed to international communications infrastructure development in various regions as a leading international supplier of optical submarine cables. A biometrics authentication system has also been adopted by over 70 countries, protecting people's safety and security. And we are supporting implementation of ICT for disaster management in many countries, using our knowledge as a country with frequent disasters. Japan is also making active strides in technology transfers aimed at making practical use of ICT. With the introduction of digital terrestrial broadcasting in Botswana, we are striving to develop businesses that make use of data broadcasting and transfer TV program creation technology. And in our communications satellite business located in Turkey, we have not only produced and delivered satellites, but have also provided high-level technology education programs aimed at autonomous development. Japan's ICT is also contributing to the optimization and increased lifespan of existing public infrastructure. In the case of Vietnam's Con Tho Bridge construction, we have introduced a system for real-time measurement of strain and oscillations. By detecting abnormalities quickly, serious damage and deformation can be prevented. As part of Myanmar's postal service, we are working to digitize money transfer services. Japan is able to offer multifaceted support for your country's growth, precisely because it possesses such comprehensive capacity for ICT development. IGCC Power Plant. The demand for coal-fired power generation is expected to see an increase throughout the world going forward. Optimizing such power generation and reducing its environmental burden are major global trends toward dealing with the global environmental issues of recent years and their application. Integrated Coal Gasification Combined Cycle, IGCC, is the cutting edge of next-generation technology for electricity generation. In IGCC, the coal is gasified and power is generated by supplying this gas to a gas turbine. And by turning a steam turbine with recovered exhaust heat, a high efficiency of 10 to 20% above conventional coal-fired power plants is achieved. IGCC also provides exceptional advances in environmental performance. The IGCC process greatly reduces emissions of CO2. It also leads to a 55% reduction in the volume of coal ash as a byproduct by emitting it in the form of glass. It is also possible to recycle this glass. Additionally, IGCC can make effective use of low-grade coal resources found throughout the world, which are difficult to use for conventional coal-fired power plants. Japan leads the world in the development of IGCC technology. We have realized the practical application of this technology through over 30 years of research and development. We have vast experience, including the commercial operation of the only air-blown IGCC plant throughout the world, with more than 33,600 accumulated hours in operation time. Japan's IGCC is a world-leading technology, opening the way for new energy development possibilities. Long-term reliability is the key to sound infrastructure. Our expertise in maintenance and preservation of high-speed rail networks has showed its true value through deployment in the United Kingdom. In 2005, new tracks were ordered from Japan after a test revealed the superior performance of our railroad. Also, the only train cars that would function during the harsh cold waves of 2010 were made in Japan, leading to greater trust in our products, as well as a decision to use them. In the latest plans for intercity high-speed rail, a 27.5-year contract was created for long-term maintenance, as well as new railroad cars. We will commit to long-term maintenance and preservation of infrastructure development around the world. In infrastructure development, unforeseen circumstances, such as planning delays and accidents, lead directly to additional cost. Development of the Purple Line in Bangkok, Thailand. We completed construction on schedule and avoided increased construction costs, despite the project being in a town area where construction work was difficult to carry out. Stainless steel was used for the cars to make them durable and energy-saving, with reduced maintenance cost. In addition, a 10-year maintenance contract was concluded, and a maintenance system was constructed locally to prevent breakdowns and ensure a stable service. Urban transportation. The establishment of urban transportation infrastructure in a world where population is becoming concentrated in major cities is indispensable. Japan possesses one of the best urban rail systems in the world and is expanding its proven track record throughout the rest of the world. The construction of the Dubai Metro utilized Japan's superior system for project management. Personnel from 42 countries and up to 30,000 people in a single day were brought together to produce the world's longest driverless, fully automated system in an unprecedented 49 months following the conclusion of the contract. The construction of the Delhi Metro included the establishment of Japanese-style safety awareness. Meticulous safety management was enforced, such as requiring helmets and steel-toe boots, as well as morning meetings. Since these protocols reduced the accident rate to less than 10% of the average throughout India, they have been established as standard safety measures for local construction. In Bangkok, Thailand, lightweight and energy-saving Japanese-style stainless steel train cars have been introduced on the Purple Metro line. Lightweight train cars helped to reduce overhead construction costs. Additionally, Japan has concluded a maintenance management contract for a 10-year period. A local maintenance system has been established to ensure stable service, and this contributes to reduced lifecycle costs. Japan's high-quality urban rail system will solve the problems of the world's cities.
Quality, resilience, and stability. Japan aims to achieve these three goals together with Africa through various activities. Building infrastructure that meets local needs and spreading Kaizen, the Japanese philosophy and production method for increased productivity. Combating infectious diseases like Ebola, saving countless lives, and promoting universal health coverage. Participating in the UN peacekeeping operations and implementing human resource development for millions of people. Our focus is to improve quality and provide empowerment. Believing in the potential that the future holds, Japan will work hand in hand with Africa.
Port development. The development of ports is a requirement for international trade and industrial development. Japan performs support that combines equipment and experience in this sector to all parts of the world. A sector that demands multiple high-class quality from planning to construction and operation. Japan drafted unified development plans for port infrastructure and industrial parks in coastal areas for Thilawa in Myanmar. Japanese technical assistance helps shorten the construction period by using the jacket construction method. Public investment primed the pump for port development, and private investment was then attracted. We supported construction based on the Japanese model, which created new employment and generated tax revenue. In the Loc Huon Port Development Project in Vietnam, Japanese ground improvement methods were used to inject a solidifying agent into the soft ground, which both shortened the construction period and produced great resistance to earthquakes, contributing to the reduction of life cycle costs. The container terminal at Mombasa Port in Kenya was expanded by guiding local personnel inexperienced in the use of technologies such as construction management and surveying. Comprehensive harbor development know-how was acquired by workers numbering more than 2,000 during the peak period. Japan performs comprehensive support for port development all over the world. Myanmar is struggling with improvement of trust in its postal service. We are cooperating with the country over the long term to improve its postal business. We are improving the quality of service with many different kinds of support. Optimized operation through introduction of dedicated fixtures. Maintenance of a human resource development system with training courses and manuals. Delivery with maximum efficiency through a review of collection and delivery routes. The list goes on. And we are also working on a proposal for post office-based business development.
The Honorable Mr. Ranil Wickramasinghe, Prime Minister of Sri Lanka, visited Kobe on April 13th during his visit to Japan. Kobe is about a 2-hour and 50-minute train ride from Tokyo on the Shinkansen bullet train. As a city developed around a port of trade, Kobe bears similarities to Colombo in Sri Lanka. At the time of the Prime Minister's visit, cherry blossoms, a flower beloved by the Japanese people, were in full bloom, and Kobe was swathed in their beautiful pale pink color. The Prime Minister first attended a lunch banquet, where he was welcomed by the Governor of Hyogo Prefecture, the Mayor of Kobe, and others.
ようこそ神戸にお見えいただきました。ちょうど今桜の満開のシーズンでございまして、桜も首相のご来信を心から歓迎しております。
I decided to visit Kobe because I told us the biomedical facilities here, which is worth looking at. It's very high standard.
乾杯!
As one of the major national strategic special zones in Japan, Kobe has implemented regulatory reforms and is home to Japan's largest-scale biomedical cluster. It is a hub of 336 organizations, including research institutes, specialized hospitals, and healthcare-related companies. The Prime Minister first visited Diken Center for Developmental Biology. Diken is one of Japan's leading research institutes. There, the Prime Minister met Dr. Masayo Takahashi, who is a renowned ophthalmologist recognized for leading clinical research to establish a treatment for eye diseases using retinal cells generated from induced pluripotent stem cells, or iPS cells. She gave a presentation about her recent work. He listened with great interest. The Prime Minister then visited the Kobe Children's Hospital. The Kobe Children's Hospital has been on the cutting edge of children's healthcare in Japan for nearly half a century. The hospital moved to the KBIC in 2016 to provide an even higher standard of care through cooperation with a variety of advanced medical facilities. The Prime Minister, who is highly interested in pediatric care, paused many times to ask questions during his tour of the hospital. Through his visit focusing on the medical sector, Prime Minister Wickramasinghe was able to learn about the Kobe's appeal as a biomedical innovation cluster.